Hello everyone, welcome to the part 2 of our second outline, which is basics with R. So in this video we are going to talk about matrices, and we will get familiar with this term by doing some theoretical and practical work. So let's get started. First of all, let's see what aspects of matrices we will cover in this video. At first we will talk about what are matrices. Then we will see how to create and name matrices. Then we will use some built-in functions on matrices. Then we will add and remove rows and columns in matrices, and we will also see how we can combine two matrices. Then we will perform some mathematical operations on matrices. In the last, we will see how to assess elements of matrices. So, what are matrices? Matrices are objects that have the same data type, which can be logical, character, or numeric elements arranged in a two-dimensional rectangular pattern or layout. Rows and columns make up its structure. A row is a horizontal representation of data, while a column is a vertical representation of data. Now you have to note down one important thing here, which is that in order to perform mathematical calculations, we mostly use matrices with numeric elements. Now you might be thinking how we can create a matrix. In R, a matrix can be simply created by using a matrix function. The basic syntax for creating a matrix is as follows. First of all, you have to use the function keyword, which is matrix. Then you have to pass down some parameters, which are data and row and column and bar row and dim names. Let's see the first parameter. It represents the data elements of a matrix that are supposed to be represented in a matrix. Then we have n row that represents the number of rows you want for your matrix to have. Then n col represents the number of columns your matrix will have. Next we have bar row that contains logical values. This logical value can be true or false. If the value is true, then the input vector elements is filled by the rows. If false, then the matrix elements are arranged by columns. In the last, we have dim names that basically assigns the names to the rows and columns. Now let's move forward. It's time to do some practical work. Let's say I have a matrix, mat1. Alright, now I will use the keyword or function of matrix. For instance, I say create a matrix that have the elements from 1 to 16 in a sequence. Now I will pass the parameter of n row as 4. That means I would like to have 4 rows, and I say n column equals to 4 and by row as true. All right. Now I will say print mat1. Let's run it. All right. Now you can see that here is your matrix. The values are 1, 2, 3, 4, 5, 6, and so on. Now here above are your column names, and here is your row names. Now let's do one more thing. I will say mat2. This time I'm creating another matrix by using the matrix function. Let's say create a matrix from 1 to 16, n row as 4, n col as 4, and this time I will pass the parameter of bar row as false, and I will print mat2 to see the difference. Now you can see here the difference. The values are represented or added in the matrix in a column layout. This is how you create a matrix. Now let's get back to slides. All right. Now you might be wondering that how you can name matrices. The way to add names for rows and columns of a matrix is as follows. The first method for giving row names is by using the function of row names. If you want to give column names, then you can use the function of column names. Now let's try to implement. All right, I will create a third matrix, mat3. I will use the function of matrix, and I say create a matrix of 16 and row as 4 and call as 4 by row as true. All right. And this time I will say row names. All right. So here I have used the function and I want to give row names to matrix 3. And what names I want to give is actually, let's say, by using the combine function, row 1, row 2, row 3, and row 4. And similarly, I will use the function of column names, and I want to give the column names to matrix 3 by using the combine function. I say column 1, column 2, column 3, and column 4. And now I will print matrix 3. Let's run it. All right. So here you can see that the names have been given to your matrix 3. Now let's get back to slides. You can also do the same by passing the parameter of dim names. Let's do it. Let's say I have a fourth matrix. Create a matrix from 1 to 9 and row as 3 and column as 3 by row as true. All right. Now here I will pass the parameter of dim names. All right. Let's say create a list of row and column. Now first of all, I must have to create two vectors such as row, and I will pass the row names row 1, row 2, and row 3. And similarly, I will say column, create a vector column by using the combine function. I will say column 1, column 2, and column 3. Now I will say print matrix 4, and then let's run it. See, it works the same. Now let's get back to slides. So let's see that what built-in functions we can use on matrix. We can use length. This function is used to find out the length of a vector. Let's do it. For instance, I want to say print and print the length of matrix 4. Well, that should be obviously 9. Next, we have the function of row sums. This function calculates the totals for each row of a matrix. Let's do it. All right, print row sums, and I want to calculate the results for matrix 4. Alright, let's run it once again. You can see that it's 6, 15 and 24 because the value of 3 plus 2 is 5 and 5 plus 1 is 6. You can do the same thing by writing call sums mat 4. Alright, now this time the value of columns are added. Now let's get back to slides. What if you want to add and remove rows in matrices? We can simply use R bind function to add single or multiple rows in a matrix. With the help of this function, one can also add two matrices together by rows. The syntax is as follows. First of all, you have to write down the R bind function, and then you have to write down the two matrices which you want to add up. Let's do it. Alright, first of all, I will say print mat4. So here we have matrix 4. And now I will say result 1. Alright, I will use the rbind function and I say I want to add a row on matrix 4, and what I want to add is, let's say 1, 2, 3. And now I will print result 1. Alright, now you can see here that we have one new row added to the matrix 4. Now let's move to slides. What if you want to add or remove columns from a matrix? We can simply use cbind function to do the same thing. Let's do it. Alright, this time I say result 2 and cbind. I want to perform the operation on matrix 4, and what I want to do is I want to add the values from 1 to 3 as a new column, and I print the result 2. Alright, a new column has been added. You can do one thing here, which is you can store into the same matrix. I will say store into mat4, and I will use the function rbind, and I want to perform the operation on mat4, and what I want to do is to add the values from 1 to 3 in the same matrix. Alright, let's print it. Mat4. Alright. Okay, this seems much better. Now let's move forward. What if you have two matrices? Let's say mat5, which is matrix and 1, 2, and row 2, and column 2, and by row as true. All right. Now I will do the same and create another matrix with the name of mat6. Let's say this time I want to create it from 4 to 8. All right. Now what I want to do is I will store the result in a new matrix. I will say rbind matrix 5, mat5. All right. And mat 6. Here it is, our print result 3. Let's run it. See, so this is how it works. Now let's get back to slides. What if you want to perform some mathematical operations on matrices? The OR operators are used to conduct various mathematical operations on the matrices. The common operations like addition, subtraction, multiplication, division, etc. can be performed out on matrices in a manner similar to what you have learned with vectors. It operates on matrices element-wise, and the operations output matrix is also a matrix. Now, one thing to note here is that for the matrices involved in the process, the dimensions, or you can say the number of rows and columns, should be equal. Now let's do it. I define a new matrix, mat 7, and I say matrix from 1 to 4, all right, in row 2, and column as 2, and bar row as true. All right, similarly, I'll say mat 8 and matrix 1 to, let's say, like 2 to 6, and in row as 2, and column as 2, and bar row as true. All right, now I want to show the result for in a matrix, and I say matrix mat 7 multiply by mat 8. All right, and then I will say print raise 4. But first, I would like to print mat 7 and 8 so that you can differentiate what actually happened. All right, let's run this chunk of code. Oh, I have made a short mistake here. All right, let's run it. Yep, it's better. Now, as we have multiplied the matrix, so 1 multiplied by 2 is 2, and 2 multiplied by 3 is 6, and so on. So similarly, this is how you perform the other operations. Now, how to assess vector elements? Using the brackets, you can assess a matrix single or multiple elements, much like you do with vectors. And a matrix item can be assessed by using the index of the appropriate column and row. The first number indicates the row position, and the second number indicates the column position. Hence, the rows from the columns you wish to pick should consequently be separated by a comma. Now it's time to do some practical work. All right, so here I have my matrix mat 7. All right, 1, 2, 3, 4. Let's say I only want to assess the first row of my matrix mat 7. So I will say pick only the first row, so it's 1, 2. Now what if I want to pick up only first column of matrix 7 and everything inside it? So it's 1, 3. If you want to access multiple columns, print mat 3. All right, that contain 4 rows and 4 columns, and you want to access multiple rows from mat 3, you will use the combine function. You will say, I want to access row 1 and row 2, and all the columns. So let's run it. It has only represented the rows which were mentioned here. This is the end of today's video. You have learned about matrices, how we can assess them, how we can perform operations on them, and how we can assign names to matrices, and what is the way of creating them. Now, good luck. See you next time.